Here I am going to explain to all of you some basic concepts of organic chemistry. Organic chemistry basically involves different types of reactions, and so uh, different types of reactions, so many reactions cannot be memorized step by step. So we have to develop a technique by which we can easily grasp the basic concepts of the reactions. For that purpose we have to understand some basic concept of organic chemistry. So here I am going to explain some very basic concepts, starting from the bond fission. What is the meaning of bond fission, how it takes place? These are some points which you will see in the lecture. So reactions, you all know that reactions involves breaking of old bonds and formation of new bonds. रिएक्शंस जितनी भी होती हैं उनमें क्या होता है कि ओल्ड बॉन्ड्स जो हैं वो ब्रेक होते हैं, ओल्ड बॉन्ड्स टूटते हैं और न्यू बॉन्ड्स फॉर्म होते हैं. दिस इज द वेरी बेसिक कॉन्सेप्ट ऑफ द रिएक्शन. रिएक्शन से प्रोडक्ट जो बनता है, रिएक्शंस में रिएक्टेंट विल गेट कन्वर्टेड इनटू प्रोडक्ट, एंड इन दिस कन्वर्जन प्रोसेस ओल्ड बॉन्ड्स गेट्स ब्रेक्ड. ओल्ड बॉन्ड्स टूट जाते हैं और न्यू बॉन्ड्स बनते हैं. फॉर दिस पर्पस the breaking of bonds is very important. You know that bonds are of three types, as you have learned in previous classes that bonds are of three types: electrovalent bond, also known as ionic bonds, covalent bonds, and coordinate bonds. Electrovalent bonds are formed due to transfer of electrons. One atom transfers electrons and another atom accepts the electron, and hence oppositely charged valencies, oppositely charged species gets generated, and oppositely charged species will attract each other due to electrostatic forces. So electrovalent bonds will get formed. Now covalent bonds get formed due to sharing of electrons. These are of three types. Covalent bonds are of three types: single bond between two atoms when one electrons sharing takes place. Sharing of one electron takes place, then covalent single bond is formed. When two electrons from the both the participating atoms takes place, two electrons की sharing होती है दोनों participating atoms के थ्रू, तो डबल बॉन्ड का फॉर्मेशन होता है. इन सेम केस ट्रिपल बॉन्ड बनता है जब दोनों पार्टिसिपेटिंग एटम्स आपस में तीन इलेक्ट्रॉन्स की शेयरिंग करते हैं. दिस इज द बेसिक कॉन्सेप्ट ऑफ कोवेलेंट बॉन्ड. सो coordinate bond, third type of bond is coordinate bond, in which you will see this is the basically mixture of electrovalent and covalent bond. So for this topic you have to go in chemical bonding concept, chemical bonding chapter. I am not going into the deep formation of bond. So here is a brief discussion. So in the mechanism of the reactions, you will see in the mechanism of reactions the first and foremost step which takes place is bond fission. किसी भी रिएक्शन में आप स्टार्ट करेंगे तो उसमें आपको बॉन्ड का टूटना सबसे पहले आपको फेस करना होगा. बॉन्ड का टूटना आप देखेंगे कि कैसे बॉन्ड टूटते हैं, एंड दिस इज द वेरी क्रिटिकल एंड क्रूशियल स्टेप which cannot be judged very easily. So as the learning process will gradually increase, you will come to some facts and some rules by which you can judge the ongoing process. So I'm discussing fission of bond. Fission means टूटना. बॉन्ड का टूटना कितने तरह का हो सकता है? There are two types of bond fission. First is homolytic fission and second is heterolytic fission. I will explain it step by step. What is homolytic fission and homolytic fission? Homolytic fission of bond involves equally distribution of electrons between participating atoms. You know, if there is a bond formed between two atoms, that bond can be single bond, double bond, triple bond. I am not going into the deep of the formation of the bonds, but you briefly understand that each bond, this is the single bond, if there are two participating atoms let's say those are A and B, and this bond is formed between A and B. This is the single bond. Then one electron will be shared by A and one electron will be shared by B. This is the basic mechanism of formation of bond. In this bond there is a one electron which is shared by A and second is the electron which is shared by B. Homolytic fission involves the reverse process of the formation of bond. जैसे ही बॉन्ड बना था तो बॉन्ड के बनने में ए और बी ने अपने वन वन इलेक्ट्रॉन्स को शेयर किया था. नाउ इफ बाय सम मैकेनिज्म, बाय सम process, we can reverse this process. What is the reverse of this process? A will get its shared electron and B will also get its shared electrons. A ने जो इलेक्ट्रॉन शेयर किया था वो A को वापस से मिल गया, B ने जो इलेक्ट्रॉन शेयर किया था वो B को वापस मिल गया. Then these will be two entities formed, A and B, which will have unpaired bond electrons. These are the unpaired bond electrons. These are the electrons which have taken part in the bond formation, but due to some situation these electrons got unpaired. So these electrons have a very greater tendency to get again paired up. So these are called free radicals and these are highly reactive. You must note this point. In the organic chemistry there will be many places where you will see the formation of free radicals, and free radicals are highly reactive species. Why highly reactive? Because they have unpaired bond electrons. These are unpaired bond electrons. The presence of unpaired bond electrons makes them highly reactive. This is the basic reason why free radicals are highly reactive. So formation of free radicals in the reaction means there must be some factors by which free radical generation is favored. So step by step, this is the gradual process. As you come across many reactions, you will be aware of many factors, many situations in which free radicals gets generated. Now here I am sharing a rule with all of you that presence of sunlight is an indication of free radical generation. If in any reaction sunlight is present and some factors must also should be in favor, like some solvent must be there, or presence of peroxide. If any type of peroxide, benzoyl peroxide, hydrogen peroxide, this type of compounds if present in the process of the reaction, then also the free radical generation is favored. So note here 3 points: presence of sunlight, presence of any solvent, any type of solvent like benzene, carbon tetrachloride, these are the organic solvents. So presence of solvent, presence of sunlight, and third very important point, presence of peroxide. If any type of peroxide is present, then 98% we can predict that the reaction will follow free radical mechanism. So now here I am going to explain an example in which free radical generation takes place. That is the very well known reaction, that is halogenation of alkane in presence of sunlight. Halogenation of alkane in presence of sunlight. You all know that all the 4 hydrogen atoms of methane, this is the formula of methane, all the 4 hydrogen atoms of methane gets displaced by Cl atoms. This is the first step of the reaction. And what is the mechanism of the first step of the reaction? We will briefly note the mechanism of first step. You can conclude the second, third and fourth step as the same process. I have told you a rule, that is presence of sunlight favors free radical generation. If there is a presence of sunlight in the process of reaction, then you can expect that reaction will follow free radical mechanism. So in the first step, free radical generation is favored by sunlight. Sunlight is a favorable factor for the generation of free radicals. Now where free radicals will be formed? Free radicals are formed free radicals are formed very easily where electronegativity difference is very low. Free radicals are formed very easily where electronegativity difference is very low. जहाँ पे इलेक्ट्रोनेगेटिविटी डिफरेंस बहुत कम होगा वहाँ पर फ्री रेडिकल्स बहुत आसानी से फॉर्म हो जाएंगे. तो यहाँ पर आप देखिए जो स्टार्टिंग मटेरियल था आपका, देयर वाज मेथेन एंड क्लोरीन. In the chlorine, you know, Cl2 is the formula of chlorine, and there is a single bond between both chlorine atoms. This single bond is formed by the sharing of 1 electrons by both the chlorine atoms. So electronegativity difference between these two atoms is negligible, zero. The electronegativity difference between these two atoms is zero. So in the presence of sunlight, these two atoms will homolyze itself by actually attracting each electrons from itself. इन लोगों ने जो अपना अपना एक एक इलेक्ट्रॉन दिया था वो वापस से ले लेंगे और खुद को क्या करेंगे, होमोलाइज कर लेंगे. दिस विल बी एन एग्जांपल ऑफ होमोलिटिक फिशन that is favored due to sunlight, presence of sunlight. So this will be the first step of the reaction in which two chlorine free radicals will be generated. This is a very highly reactive species because there is an unpaired electron present in the last cell of the chlorine, so it is highly reactive. Now come across another rule that is also very important. These are the very small rules but of very importance. You can understood these rules, grasp these rules और इनको आप memorize कर लीजिए, because without application of these rules you cannot get the actual picture of the mechanism of reactions, and without the mechanism of reactions you can only learn, you can only understand, you cannot understand the basic principle hidden behind the chemical reactions. So mechanism of the reactions is very important, and in the 12th standard it is a very obvious process. Now free radical generates free radicals. If in the reaction process free radicals are getting generated, if first step follows free radical mechanism, free radicals are generated in the first step of the reaction, then ongoing all the steps will also follow free radical mechanism. बिल्कुल बेसिक सी बात है समझने की. अगर कोई पॉजिटिव चार्ज स्पेसी है, इफ देयर इज अ स्पेसी known as example A plus, this is an species which has a positive charge. If it wants to combine with another species, then there will be presence of a negative charge on this species, then only A can get combined with the B. This is the basic principle, because after combination A and B there will be a neutralization of the charge, and due to neutralization and an electron valent bond will get formed. By this process an electrovalent bond will get formed. You cannot join A plus and B plus because same charges repel each other, same charges will repel each other. In same manner you can explain that free radicals can only get paired up, or free radicals can only get combined with free radicals only, because if there is a unpaired electron present with A and there is another unpaired electron present with B, then pairing of electrons is necessary for the bond formation, and pairing will only take place when free radicals only get contacted with each other. जब केवल free radicals एक दूसरे के पास आएंगे तभी उनके इन unpaired bond electrons के बीच में pairing हो पाएगी. This is the very important step. So you can understand this rule very easily, that free radical generates free radical. बिकॉज इसमें इन्हीं का फायदा है। अगर फ्री रेडिकल एक बार बना तो वो पूरी रिएक्शन में फ्री रेडिकल मैकेनिज्म को फॉलो कराएगा, बिकॉज अगर एक बार फ्री रेडिकल बना तो आगे भी फ्री रेडिकल्स के बनने पर ही उन फ्री रेडिकल्स का कॉम्बिनेशन संभव होगा, उन फ्री रेडिकल्स का कॉम्बिनेशन पॉसिबल होगा। सो देयर इज अ वेरी इंपॉर्टेंट step, important progress with the methane. There are 4 hydrogen bonds and all the 4 hydrogen bonds with the carbon are equivalent. So we can homolyze any of the carbon hydrogen bond. We will homolyze this bond will homolyze itself to produce methyl free radical and hydrogen free radical. This is a very easy step, you can understood very easily. So here I have written that hydrogen free radical is comparatively more reactive. Comparatively more reactive means it is more reactive than methyl free radical. How can we come across these types of results? ये हम कैसे जान सकते हैं कि this is the more reactive, this is less reactive? So understood this process very carefully. Reactivity depends upon stability. Reactivity depends upon stability, as this species is highly unstable. If this is unstable compared to this species, then instability leads to reactivity. जो एटम, मॉलिक्यूल, आयन, फ्री रेडिकल जितना ज़्यादा अनस्टेबल होगा वो उतना ही ज़्यादा रिएक्टिव होगा। जिस भी स्पेसी में जितनी ज़्यादा अनस्टेबिलिटी होगी उसमें उतनी ही ज़्यादा रिएक्टिविटी होगी, और कोई भी ऐसी स्पेसी जो जितनी ज़्यादा स्टेबल होगी वो उतनी ही कम रिएक्टिव होगी। सो रिएक्टिविटी डायरेक्टली कंबाइंस विद द डायरेक्टली कैन बी जज्ड विद द fact of stability and instability. So here we are going to compare the comparative stability of both the free radicals. So how can we judge about the stability of the free radicals? Stability of free radicals is compared by their size. We can judge this factor by their size. हम फ्री रेडिकल्स की स्टेबिलिटी को उनके साइज से पता कर सकते हैं कि शेप और साइज कैसा है। स्मॉलर है साइज में फ्री रेडिकल या लार्जर है साइज में। सो फर्स्ट रूल इज स्मॉलर द साइज ऑफ फ्री रेडिकल लेसर विल बी इट्स स्टेबिलिटी। फ्री रेडिकल का साइज जितना छोटा होगा, फ्री रेडिकल का आकार जितना छोटा होगा वो उतना ही अनस्टेबल होगा। स्मॉलर द साइज ऑफ द फ्री रेडिकल, smaller the size of the free radical, lesser will be its stability. Memorize this rule very carefully. As size of free radical increases, जैसे जैसे free radical का size increase करता है वैसे वैसे its stability also goes on increasing. इसकी stability भी वैसे वैसे बढ़ती जाती है. So here are 4 rules. Presence of sunlight, free radical generates free radical, and the stability comparison. These are the basic points which you should note down during the process of watching the video, because if these points will skip then you will not understand the sole purpose of the video. So here is an advice, please watch the video with a pen and copy. There should be a pen and copy in front of you. If any types of these important rules are spoken, then you should immediately note them down in your notebook so that they can help you in the further study process, and they will surely be helpful for you in your further ongoing study process. From here we can understood that methyl free radical is larger in size. Methyl free radical has large size compared to hydrogen free radical. Larger in size means more stable. More stable means less reactive. Note this point very carefully. More stable means less reactive. Now hydrogen free radical is lesser in size compared to this methyl free radical. In fact, or in general, hydrogen free radical is the smallest free radical in the reactions generated. So hydrogen free radical will always be very reactive because it is very lesser in size, so more reactive compared to methyl free radical. So what will be the next further development, next further process? So hydrogen free radical is more reactive. The more reactive hydrogen free radical will be moving faster, to get combined with any other free radical, because it wants stability very rapidly. It wants to get stabilized very soon. So hydrogen free radical will first combine with chlorine free radical generated in first step. The chlorine free radical which was generated in the first step of the reaction, this chlorine free radical will get combined with the hydrogen free radical to give HCl. Here pairing of both unpaired bond electrons has lead to bond formation. This will be the single bond, covalent bond formed between hydrogen and chlorine, and this will lead to formation of HCl, hydrochloric acid. Now in the system there will be one chlorine free radical remained, one chlorine free radical will remain in the system, and one methyl free radical will also remain in the system. These both free radicals will also get combined with each other to generate chloromethane. This is the first step of this reaction. Now again one another molecule of Cl2 will get homolyzed to give 2Cl free radical, and from here also carbon and hydrogen bond will get homolyzed to produce this free radical. This free radical will again get formed. One Cl free radical will get consumed here, and one Cl free radical will get consumed here. So in the second step, two hydrogen atoms will get replaced from the methane, from the carbon of the methane, and in the successive steps all the four hydrogens will get replaced by the Cl atoms. This is the reaction which follows free radical mechanism. In the next video I will be having a mechanism which is very important using anti-Markovnikov rule. So in that reaction also free radical mechanism is used. In that reaction also we will be applying all these rules which we have discussed today. So learn these steps, work on these steps. I will be having next very important reactions, that is hydrohalogenation of alkene in presence of peroxide, which use anti-Markovnikov rule. So we'll be explaining it tomorrow. Thank you.